Let's start with the fact that physics does not directly prohibit teleportation. But on the other hand, if we think about it, physics doesn't really prohibit anything directly, so when such opinions are expressed in various articles that attempt to analyze this question, one could generally say that the appearance of a dragon behind my back is also something that physics doesn't prohibit. Therefore, we need to dig a little deeper here. However, this point that physics does not prohibit should be kept in mind, and one important conclusion needs to be made. In fact, it does not violate the laws of nature as such, and therefore also the laws of physics. What can teleportation be? Well, it is essentially the disappearance of an object in one place and its appearance in another place. And here, several physical thoughts immediately arise. First, what is an object? What is a material body? An object must have certain coordinates in space and time so that we understand where the object is located and where it actually needs to be transferred. Third, one needs to understand how the process of teleportation can actually take place. What physics could be behind this? Having raised these questions, let's try to answer each one. Matter. Well, the topic of matter is a long story. And, in general, we have come to the conclusion, many times, that matter is directly related to energy. And in fact, any particle can somehow relate to, let's say, a special form of energy. Of course, it is not written directly in textbooks, but this version does not deny the main essence that, so to speak, big science is trying to convey to us. The next point is the coordinates in space-time. Well, we remember that there is such a characteristic that allows us to describe the location of an object in space. In fact, a coordinate in space is the same as a coordinate on a plane, just with an additional dimension and an additional metric. Therefore, I think there are no problems with the space-time coordinate. The word time here is drawn from a larger theory, which is not particularly significant for us right now, because, in fact, teleportation does not imply movement through time. And we bring space-time into this discussion for one simple reason, because at one time, Einstein dealt with these questions, and generally all of this is associated with the name Einstein, and space-time goes hand in hand. There was also a video on this topic on the channel. Take a look, we won't repeat ourselves. How can matter that is located at a given coordinate be transferred to another coordinate? One might think that this question is purely unscientific, or that we should start from the simplest mechanical action, where we take something, for example, a helmet or something else, and move it from here to there. This is the simplest way of teleportation. And now let's imagine that we need to somehow do this without the involvement, so to speak, of some factor that allows everything to move. If we have a body located here, and we need to move it over there, then to do this, we need to utilize the distortion of space-time. In order to explore space-time, one needs to do something incomprehensible. Technically, it can be assumed that if we can influence space and time with some external factor, then some kind of wormholes or other interesting phenomena may form, which would allow connecting one point in space to another point in space. So it turns out that if an object falls into some distortion or vortex here, it can appear here because there will be some tunnel in space-time connecting the 2 points, and in fact the object is, so to speak, teleported. As far as I remember, there was something called the Philadelphia experiment. I don't recall the details, but the essence was that there was an attempt to affect space-time using strong electromagnetic fields. And all of this eventually resulted in a famous fantasy or science fiction film, where in general this is what was achieved. It is worth noting one thing for us. If we can influence space in one way or another, and if such a method emerges, then by distorting space, we can move one coordinate to another, which means we could move objects without physically participating in the process. In fact, this is what we will call teleportation. An object will disappear in one place and appear in another. There will be no need to apply any mechanical or non-material influences. Nothing at all. It will simply disappear and reappear at another point. The next interesting method is, roughly speaking, to disassemble matter at one point and assemble it at another point. However, here we encounter many questions that accompany this idea. Firstly, we do not fully understand what matter is. But let us assume that we represent matter as a set of certain atoms. Atoms themselves are not exactly individual. Yes, atoms of different elements differ from each other, but that does not mean that 2 lithium atoms will differ from one another. If you dig deep enough, there are indeed differences because there can be variations, such as isotopes or something similar, and in principle you can gather some evidence to say that yes, they are actually different. However, they are not so different that the materials would vary significantly. So what does it come down to? If we disassemble an object into atoms at one point, then we can hypothetically assume that at another point we can assemble a different object from these atoms. Firstly, it is not a fact that atoms will appear in the place where we assemble the object from scratch. Secondly, it's interesting that we do not fully understand how to assemble matter from all of this. There is a hypothesis that, roughly speaking, one can simply take atoms and assemble matter. Such experiments have been conducted. And such experiments were successful, but there is no understanding of how to make that substance into the substance that was originally there.